Okay, let's give this a shot. I've never done this kind of thing before, but it's worth a try. I'm going to do problem number 5. Yeah, problem number 5 from the Osmosis and Diffusion practice worksheet. The first thing I'm going to do is draw my cell. My cell is 38% glucose, 15% sodium, 3% potassium, and 5% starch. It's a lot of stuff. And the solution, here's my beaker. I think I can change color. Can I change color? Let's see. Look at that. That's amazing. And my solution is 40% glucose, 20% sodium, and 1% K+. All right. You guys are pretty good at drawing those things, so yeah. Now the first thing I do, and what I'm going to do is I'm going to follow the helpful hints list that's on the front page of the packet. We're going to look at one substance at a time, and we're going to think about where the substance is more concentrated and what direction the substance will move. So, according to the front page, the membrane is permeable to glucose. So, there's more glucose outside the cell. I'm going to put a little arrow up here for that. And there's less glucose inside the cell, so some of the glucose is going to move. Some of the glucose is going to come into the cell. Let's see what our next one is. We have sodium. There's a higher concentration outside the cell and a lower concentration inside the cell. So some of the sodium is also going to come inside the cell. There's more potassium inside the cell. There's less potassium outside the cell. So some of the potassium is going to come out. And starch is impermeable to the membrane, so it can't move. So let's think about this now. 40% glucose outside the cell, 33% inside the cell. After we're all done, after everything is done moving, the outside of the cell and the inside of the cell should have the same percent of glucose. There's 7% difference between them, which means that 3.5% of that glucose is going to go inside the cell, bringing the inside of the cell up to 36.5% glucose, and then the outside is also going to be 36.5%. The sodium difference is 5%. There's 20 outside, 15 inside. So when it's all said and done, 17.5% will be outside and 17.5% will be inside. That's for the sodium. For the potassium, there's a 2% difference. So when we're all done, we're going to be 2% potassium outside, and 2% potassium inside. But the inside is still going to stay 5% starch. Now, if we add all these up, let me do the math here. So 37, 17, that's going to be 47.53 plus 7. That's going to be 60% solutes inside the cell, which gives us 40% water inside the cell. The outside of the cell is going to be 36.5 plus 17.5. That gives us 37, 47, 54 plus 2 is 56% outside, which means the outside is going to be 44% water. So there's a little bit more water outside the cell than there is inside the cell as far as concentrations go. So some of the water is going to come inside the cell. So when we look at our questions, we can see, will osmosis occur? Is letter B. And the answer to that is yes. And it will move inside the cell. Will any other substances diffuse across the membranes? The answer to that is yes. inside will be glucose and sodium, and out will be potassium. Will the cell shrink, swell, or remain the same? Well, since some water comes inside the cell, then the answer to D is that the cell will swell a little bit. And is the solution in the beaker hypotonic, hypertonic, or isotonic? Well, since there was a higher concentration of stuff inside the cell, then that means that the solution had a lower concentration of stuff, which is hypotonic. Where am I now? Oh yeah, letter G. If you add iodine, what color would the solution in the beaker be? Well, there's no starch out here. There's no starch out here in the beaker, and so if you dump iodine out here, it's just going to stay brownish yellow.